Okay, it's Math 6, Unit 2, Lesson 15, called Part-Whole Ratios. So first of all, we're going to look at some true-false statements about multiplying by a unit fraction, just deciding if these are true or false. That's the first part of the day today. So here we have 1/5 times 45, and we know that when we do 45 times a fifth, we actually end up with 45 over 5, because 45 times 1 is 45, and 5 times 1 is 5. So those are actually going to be the same. So this is going to be true. It's a true statement right there. Okay, so division, 45 divided by 5, is the same as multiplying by the reciprocal. So the idea there. So that's what we got there. Alright, part 2 here, we have 1/5 times 20 and 1/4 times 24. If I was to put those together there, you end up with 20 over 5, right? And over here you end up with 24 over 4. We could reduce those if you wanted to, but even by reducing them, 20 over 5 becomes 4, and 24 over 4 becomes 6. So those are not going to be the same. That's not going to work there, right? Different denominators, both fractions are just increased in a different amount, just not going to work out. Here we have 42 times 1/6 and 1/6 times 42. We call this, you remember, the commutative property of multiplication, which basically means it doesn't much matter which order you put these in, we're still multiplying, and so it's still going to come out the same. And finally, last one here, we have another statement that we have 486 times 1/12, which becomes a total of 486 over 12, right? So this is 480 over 12 plus 6 over 12. Well, because the denominators are the same here, we can add 480 and 6, and we have 486 over 12, so I end up with the same exact thing, so that's going to be true as well. So I had a true, a false, a true, and a true statement. Let's take a look at today's activity. It's kind of a new topic today as we wrap up this unit, get close to the end. It says that, well, before we start here, before we get to this thing, it wants me to show you a little bit about how to make some green paint, okay? So if I was going to make some green paint, I would say that I need to have 3 parts yellow, okay, maybe 3 milliliters of yellow, for 1 milliliter of blue in order to make a certain type of green paint, okay? So I have a cube here to represent each milliliter of paint that I would use. 1, 2, 3 yellow, and 1 blue. Okay, so this is like our ratio here, but we can see how each of these is going to be, 1 part of the green paint. Okay, so if I have 3 milliliters of yellow and 1 milliliter of blue, how much green paint, would I have when I mix this up? Yep, I'd have 4. 1, 2, 3, 4, because I'd combine them together. This works with things like paint. It doesn't work with everything, right? If I'm adding flour to a cup of flour with a cup of water, I don't end up with 2 cups of mixture there. It just doesn't work out the same because of just the way products interact together. But with the paint thing, it does work out this way, okay? So if I was to combine those, I'd have a total of 4 milliliters. But the thing about today, what we're looking at today, is what if each of these, instead of being just 1, stood for 2 milliliters? This was 2, and then 4, and then 6, and this was another 2. That would make a total of 2, 4, 6, 8. So it becomes a simple way of showing the same ratio again and again, and just changing the value of each one of the cubes, so that overall we can see how we're doubling something, making a new batch of something like we used to do before in our other units. Okay, so this becomes our little green, our exciting green paint, which has 3 parts and 1 part, and there we go. So that's our green paint. We'll come back to that in a little bit. So this next one says, a recipe for maroon paint says mix 5 milliliters of red with 3 milliliters of blue paint. Use snap cubes to represent the amounts of red and blue paint in this recipe, then draw a sketch of your snap cube representation of the maroon paint. Okay, so here's our maroon paint. We're going to draw this right here. We have what? We have 5 red, 1, 2, 3, 4, 5, and we have 3 blue. 1, 2, 3. And either my camera is looking funny, mine almost looks like this is like brown or something, but oh well, it's red. So I have 5 red and 3 blue. So if I was to draw this out, like sketch it, what it looks something like this. Let's keep the order here. we have 5 of these. Let's go 5. And 1, 2, 3, 4, 5. And then we have 3 blue, like this, right? And that's the idea there, right? So we have a red, a red, a red, a red, a red. We have a blue, and a blue. All right, what amount does each cube represent? In this little picture here, this I don't know, what are you going to call it? This thing, we would say each one represents 1 milliliter of paint of a certain color, right? 1 milliliter of red, 1 milliliter of blue, whatever that's going to be. So in this representation, how many milliliters of maroon paint will there be? Well, in this case, I'd have 5 plus 3, right? I have 5 here, I have 3 here, and if I add those up, I end up with 8 milliliters of paint. Okay, so it works out pretty nice. I can show that these would be combined, 5 of those, 3 of those, makes a total of 8 milliliters of paint. Where it gets, I don't know, I guess fun for me, is when you can use these snap cubes like this to be able to show that if a cube represents 2 milliliters, we can then figure out how much of each color paint there is as well. So instead of thinking of these as being 1, watch what happens. If these are 2, then how much red do I have? We have 2, 4, 6, 8, 10. So 10 there, and blue becomes 2, 4, 6. And altogether, we'd have a total of, we can combine those, 10 plus 6 to get 16 milliliters. Okay? So what I'm doing is I'm saying each one of these has a value not of 1 now, but of 2. I could do the same thing in part B where it says, well, let's pretend they each have a value of 5. Well, how much red is there going to be? I have 5, 10, 15, 20, 25. Another way of thinking about it is I have 5 red. I'm going to say the value is 5 each, so 5 times 5 is 25 milliliters. I have 3 blue, so I have 5, 10, 15, or notice here, because each one has a value of 5, 3 times 5 is 15, and my total, I can either add them up, 25 plus 15 is going to be 40, or I can recognize that in total still, I still have 8 blocks, and 8 times 5 is 40 as well. Alright? So, on the next one it says, well, suppose you need 80 milliliters of maroon paint. How much red and blue paint would you mix? So if I had to get to 80 here, let's look at the next one. Right? If I had to get to 80, 80 is a lot more, but I need 80. I know that I have already 1, 2, 3, 4, 5 red, and I have 3 blue. I need to get 80 total, 80 milliliters. Alright, so here's my 5 and my 3. How much am I going to need to get to 80 milliliters? Okay, so this is my 5 red and my 3 blue, and I know I have to get to 80 in total. That's my 80 right here. So what we can do is we can say, well, let's think about how much each one of these squares needs to be. When it was 8, when I was looking for something that was just 8, each one was worth 1. When it was going to be 40, each one had a value of 5, right? So when it was 40, each one had a value of 5. All my 8 had a value of 5. So what we're doing now is we're saying, well, I want to get to 80. I know I have 8 cubes, so what's the value of that, of each cube to get me to 80? Or 8 times what number gets you to 80? So we can think about it that way, or we could simply do 80 divided by 8. So if I do 80, my total number, divided by the number of cubes, which is 8, it tells me the value of each cube, because each cube has the same worth. So 80 divided by the number of cubes, which was 8, tells me that every cube would have a value of 10. 10, 10, 10, 10, 10, 10, 10, and 10. So how many milliliters of red would I have? I would have 5 times 10, or 10, 20, 30, 40, 50. I'd have 50 there. And the blue would be 3 times 10, or 10, 20, 30 there, which does add up. 50 plus 30 does match my 80 there. My picture wouldn't change at all, or my graphic representation here wouldn't change at all, because this becomes 10, 20, 30, 40, 50 red, 10, 20, 30 blue, for a combined 80 to make the maroon that I need. If the original recipe is for one batch of maroon paint, how many batches are in the 80 milliliters? Well, in this case here, to get to the 80, it took 10 of those because every unit went from being 1 to being a value of 10, and that 10 represents our batches. All right? So we can show this, and what we're talking about here is what's called a tape diagram. This is what we talk about. We talk about tape diagrams here. It's basically a horizontal strip that is partitioned into parts, like we just did. So we take a horizontal strip like this, and we partition it into parts. 1, 2, 3, 4. And we partition it into equal parts for this point. Okay. Each part, like the snap cube, represents a different value. This is what we call a tape diagram, and we're going to use more of these throughout the year and this unit as well. So that's our tape diagram. This was our red, and this was our blue. But what's nice about it is that each one of these can have whatever value we assign to it, right? We could say that 1 square is equal to 1 milliliter, and from that we can do some math and figure things out. Or we could say that 1 square is equal to 10 milliliters, like in our last problem, and it changes things, but yet our diagram, our tape diagram, remains the same. So it gives us a little more flexibility there, right? So when you go back to what we started with our green paint, we talked about the green, where I had 3 yellow and 1 blue, right? If I wanted to make 20 milliliters of green, if that was my goal there, okay, could I make 20 milliliters of green? Sure. I'm going to take the 20 and I divide it by the number of cubes here, or parts. 1, 2, 3, 4, divided by 4, which would mean that I have 5. What does that mean? I have 5, I only see 4. 5 becomes what? 5 becomes the value of 1 cube. All right, so 1 cube has a value of 5. In this case, 5 milliliters. So if I was to draw it out like this, I would say my yellow is here, my blue is here, and each one has a value of 5 milliliters, and 5 milliliters. So in total, I would have 20 milliliters of green paint by adding 1, 5, 10, 15, 20 to make that work there. So each part's going to be equal, and so I ended up with 5 milliliters of green paint. That's the way a tape diagram works, and we're going to be working on more of these. You can use the snap cubes if you need to from time to time, but you can also draw your boxes and try to line that up there so they look the same and proportional there. Let's take a look at the next one. Next is called Sneakers, Chicken, and Fruit Juice. So 3 different tape diagrams to make here. Solve each problem. Show your thinking. If you get stuck, consider drawing a tape diagram to represent the situation. The ratio of students wearing sneakers to boots is 5 to 6. If there are 33 students in the class, all of them wearing either sneakers or boots, how many of them are wearing sneakers? Alright, so let's take a look here. Let's do a sneakers to boots. Sneakers is going to be 5, so I'm going to make a little bar like this. I'm going to go 1, 2, 3, 4. Gives me a total of 5 squares. Let's see my sneakers. And boots is 6, so I know I'm going to go past the 5 and go 1 more. So I have 1, 2, 3, 4, 5, 6. That's my boots. Okay. We have 5 sneakers. We have 6 for the boots. That's my ratio, 5 to 6, right? So 5 to 6 is my ratio, and we're drawing it there like so. And we know that there are a total of 33 kids. Well, in my ratio, I have 5 and 6 make how much? 11, right? So if we do 33 divided by 11, that will tell me the value of 1 square. 33 divided by 11 is going to be 3, so that tells me that 1 square equals 3 students. Right? That's what it's going to be. So while there's 5, those 5 squares represent 3 students each. This is 3, 3, 3, 3, and 3. So if it's wanting to know how many of them are wearing sneakers, we can do 5, in this case here, because there's 5 sneakers. 5 sneakers times the value of each box, which is 3, to tell me that there are 15 students wearing sneakers. Pretty cool. Let's do another one. Let's do one for the chicken marinade. It says mix 3 parts of oil with 2 parts of soy sauce and 1 part of orange juice. So now we have 3 things going on, right? So we have, first of all, 1, 2, 3. This will be our oil. We have our soy sauce, which is 2. And then we have our 1 part of orange juice. All right, so that's what we have. All together, we need to make sure that we have 42 cups of marinade in all. So we know we have some cups of oil, cups of soy sauce, cups of orange juice. We have a total of 42. So when I look at how many parts I have 3, 4, 5, 6 parts altogether. So if I take my 42 cups and I divide it by the number of cups that I have here, that will tell me the value of a box. So 42 divided by 6 is going to be 8. So I now know that 1 box equals 8 cups of whatever it's going to be. Oh, 8. Sorry, 7. Got ahead of myself. Good catch if you caught that there. Nice job. So 7 cups. There we go. Handy thing about the eraser. Just change your answer. So 7 times 6 is 42, so 7 cups. Meaning if this is 7 cups of oil, 7, 7, 7, 7, 7. At least for the recipe we're going to make right now. Right? I could change the amount, I could double it and it would change, but for this one, that's what we have. So what do we know then? How much of each ingredient? Well, for the oil is going to be 3, because there's 3 of them, times 7 cups for 21 cups. For the soy sauce, we have 2 times 7, which is 14 cups. And for the orange juice, we have 1 times 7, which is 7 cups. So that's the number of cups of each ingredient we need to make this marinade in the recipe that it's wanting us to make it in. Could it be less? It could be, but for this recipe, it wants 42 cups, and that's how we get there. Because if you add all those up, you end up with 42 cups. Let's take a look at Elena making fruit punch. She mixes 4 parts cranberry juice, 3 parts apple juice, and 2 parts grape juice. So let's get a 4. Here's a 4 right here. Sure it is. 1, 2, 3, 4. That's our cranberry juice. Our apple juice, it said, was 3. So we'll go 1, 2, 3 like this. Apple juice. And our grape juice is 2. And there we go. If one batch of fruit juice is 30 cups, or includes 30 cups of apple juice, how large is the batch of fruit punch? So, if this is going to be 30 cups, just this line right here, this is 30 cups, then what's the whole thing going to be? Well, this 30 is going to be 30 divided by 1, 2, 3. If I divide it by 3, that will tell me the value of every one of the squares, which is going to be 10 cups. So everyone is 10 cups, right? How many cups do I have total? I have 4, 5, 6, 7, 8, 9. So I multiply that by 9, and we end up with 90 cups. Okay, if you weren't sure, I could do it this way. I could do I could do the cranberry juice is going to be 4 times 10, which is 40. The apple juice, which is going to be 3 times 10, which is 30. And the grape juice, which is going to be 2 times 10, which is 20, and still add them up for 90. Okay? And that's the idea right there. Let's take a look at your summary. I'm going to skip the next part. We're going to go to the summary here, because you got the idea for what we're doing today. The summary just says that a tape diagram is another way to represent a ratio. All the parts of the diagram that are the same size have the same value. So if they're the same size, they have the same value. Later on we'll see, how that sometimes we could change those squares around to make different values, but if they're the same, they represent the same thing. Alright? So in this case here, ducks and swans is 4:5 ratio, looks like that. But it's also kind of cool because sometimes we can say, well, we know there's 18 of the birds in the pond, we want to know how many. We could look at the whole, and we could divide that, 18 divided by 9 little squares, to find out, each one represents 2. So with a tape diagram, you can do some quick math there, and it works out pretty well. Let's pause there and work on your homework. We'll come back together in just a minute and see how you did. Okay, homework trick time for lesson 15. It says, here's a tape diagram representing the ratio of red paint to yellow paint in a mixture of orange paint. What is the ratio of yellow to red? We're looking for yellow to red. In this case here, the yellow is 1, 2 yellows for 3 reds. 1, 2, 3. That's our ratio there. Okay? The ratio just wants to know how many of each part. We have 2 and we have 3. Make sure you get the order right. Okay? That's why I wrote yellow, red. How many total cups of orange paint will be in this mixture? Well, the total is not going to be 2 plus 3, because why? Every one of these squares stands for 3 cups, right? So for the red is going to be, I have 3 red times 3 cups each, that's 9. The yellow, I have 2 yellows times 3 cups each, which is going to be 6. So in total, we're going to have 15 cups of orange when it's all mixed up. Number 2, at the kennel, the ratio of cats to dogs is 4 to 5. Cats 4, dogs 5, 4, 5. There are 27 animals in all, so altogether there are 27 animals in all. Here's a tape diagram. What's the value of each small rectangle? To find the value of the rectangle, we take the total number, 27. We divide it by the number of squares. The number of squares that we have happens to be 9. And that'll tell us the value of one square. 27 divided by 9 is going to be 3. So every one of those is going to be worth 3, 3, 3, and so on. Now, how many dogs are in the kennel? I know that there are 5 squares. Each square equals 3. 5 times 3 is 15. How many cats? There are 4 squares. Each square equals 3, and 4 times 3 is 12. Okay, number 3. Last month there were 4 sunny days for every rainy day. Okay, so we have sun, I'll use the space here. We have sunny, and we have rainy, and we have 4 sunny for every 1 rainy. Way to go. If there were 30 days in a month, how many rainy days were rainy? Okay, or how many days were rainy? So we had a total for 5 days. This becomes this plus this is going to be a total of 5 days, right? Or 5, our ratio is 5. So if I take 30 and I divide it by 5, I end up with 6. So as a tape diagram, I might have something like this. I might have 4, 1, 2, 3, 4 to 1. This is my sunny, this is my rainy. So if every one of those is a value of 6, and the question then is how many days were rainy, I do 1, I have 1 box times 6 is the value of each box, to say 6 days in a month of 30. That's the idea. Okay, number 4. Noah entered a 100-mile bike race. He knows he can ride 32 miles in 160 minutes. At this rate, how long will it take him to finish the race? Use a table to find the answer. Next, explain which table do you think works better in finding the answer for how long it'll take him to finish the race. Let's look at our table in the next one. So here's our table. We have 2 different ones here. So we will first of all take a look at this one. To go from 32 to 1 means multiplying by a 1/32, and 160 divided by or times 1 over 32 is actually equal to 5. Okay, and so to go from 1 to 100, for how many miles you're going, that's going to be multiplying by 100. 5 times 100 is 500. So how long will it take them to go 100 miles? We would say 500 minutes. Okay, not too bad. The trickiest part here is doing the division of 160 divided by 32. Okay? On this next one, we can see we have 32 miles in 160, just like before. And we can see that what they decided to do is say, well, let's multiply this by 3. When you multiply that by 3, we're getting close to 100 is the idea, right? That's the idea. So we multiply this by 3. And 160 times 3 gives 480. Okay, so that's not bad. So we know we're close. We need to go 4 more miles because we're only at 96. To get to 4, you can do 32 times 1/8 because 32 divided by 8 is 4. So if I thought about 160 times 1/8 or 160 divided by 8, I would end up with 20. All right. So now 96 plus 4 gives me 100. Just as the 480 plus the 20 give me 500, like that. So, does it work? It certainly does. Is it ideal? It depends on what you see. You know, this might be easier for you. This one seems to be easier, but you do have to deal with a funny little fraction to start off with, or a funny division problem. All right, number 5. A cashier worked an 8-hour day and earned $58 right there. So 8 hours, $58. The double number line shows the amount she earned for working different number of hours. For each question, explain reasoning. How much does a cashier earn per hour? Well, we don't have a per hour here, do we? We can see that per hour would come right here on the 1, which means if I took the $14.50 for 2 hours and divided that in half, 50 divided in half, that would tell me how much she makes in 1 hour. 2 goes into 14 7 times, right? And we have a 5 there. 2 goes into 5 2 times. Bring that down, and it goes into 10 there. So how much does she make per hour? She makes $7.25 per hour. All right, because that's half of $14.50, $7.25. Now, what does she work for 3? What does she make for 3 hours? Well, we take our unit rate of 1 hour times 3, and we have 15, we have 7, we have 21, 2 behind the decimal, 1, 2, and we have $21.75 is what she makes for 3 hours. All right, and our last one here says a grocery store sells bags of oranges in 2 different sizes. We have 3 pounds for $4 and 8 pounds for $9. Which oranges cost less per pound? So we're going to do oranges per pound is the idea there. So let's make a little table here and see what we have. Okay, so we have in the first one, we know we have 3 pounds costs $4. In the second one, we have 8 pounds costs $9. Right, I can't really compare those two things right away, but let's do this. I know that if I bought the same, let's pretend we bought the same number of oranges, right? So to do that, let's find a common multiple. I'm going to go with 24, because 8 times 3 is 24. So to get from 3 to 8, 3 to 24, that's times 8. So what's 4 times 8 here? That becomes $32. To get from 8 to 24, that's times 3. So what's 9 times 3? That's going to be $27. So which ones cost less per pound? Well, if I bought the same amount, 24, this one here is a better deal. It only cost me $27. I actually saved $5 by going to that store right there. You could do it other ways too. You could find the unit price, okay? And that's another way of doing it here. If you did that, you would take a look and say, you know, it's the orange per pound. And so you would say, like in this one here, you could have your $4, and you divide that by 3, and you find that it costs $1.33 per pound for the first one. This one you would take your $9 and divide that by 8, and when you do that, you find that it costs $1.12, right? So this one has the cheaper per orange rate. This is $1.12 per orange, that's $1.33. Either way, you still save money with the 8 pounds for $9 method. All right, that's it for today in this lesson, and we will see you next time. Have a great day.